We are live.
Okay, thanks.
Maybe we can wait 2 minutes for everyone to join.
Yeah, just ping me when everyone is ready. Okay.
Sure. Yeah.
You ready?
Uh, we can wait for 1 more minute.
Sure. I think it's not 5 yet. I guess now it's 5.
All right. So I think it's 5. We can start our session.
Okay.
So good evening, everyone. Welcome to another session on the joy of programming. So maybe it's been a long day. So here is a session to charge you all up. So we have Anand Chitipothu to give a keynote. So Anand is a passionate programmer and a long-time Pythonista. You might have seen him in a lot of Python conferences, and he has been crafting beautiful softwares for nearly 2 decades. So he's the co-author of Web.py, a micro-web framework, and he built Open Library at Internet Archive, and also created a machine learning platform at Roro Data, a startup which he co-founded. So over to you, Anand.
Thanks, Prithvi. Hello, everyone. Good evening. Hope you had a wonderful time at the conference so far. It's my pleasure to give a closing keynote at PyConfHyderabad, a community I have been associated with quite some time. Today, I want to talk about the joy of programming, something that I find these days. The fun element of programming seems to be missing in the conversations these days. When I usually ask any of the young programmers, like, what do you want to learn in programming? It's usually about AI, ML, some Kubernetes, or other modern buzzword. I feel like people are missing out on the fun element of programming. I thought, let me show a glimpse of what all things are possible with programming. So it's going to be a fun talk. Just have fun with programming. Before I start, let me kind of give a brief overview of where I come from for people who have not seen me before. I'm sure you would have seen me at any of many Python conferences. I've been in programming for about 2 decades now, and I've been using Python for about, I guess, 15 years. I started using Python around 2005. Been very active in the Python community in India. I've never missed a PyCon India, so that would give you an idea about how closely I work with the Indian Python community. I was very active volunteer in the initial years. I was leading the PyCon India conference for a couple of years. I mean, Python is my go-to language. We use Python for almost pretty much everything. Last like 3 months ago, I winded up a startup that I've been working for the last 4 years. I decided that I'll take a break and actually just have fun. All things that I wanted to do for a long time. So one thing that I also started doing was to teach programming to some young kids. So I was kind of looking at what is the fundamental ideas of programming and how do I teach, what should I teach, and how do you kind of bring the fun element and how do you get them excited about programming, right? I was trying about all these kind of ideas. So one question that came to my mind was, what is the fundamental idea of programming? Like, what is that I should teach them, right? I mean, when you look at young children, they are going to learn something. I mean, they are not going to use it right away, right? You need to learn something, and then that should remain with them for maybe 10 years. So what are the fundamental ideas of programming that I can actually pass on to them? So I was kind of thinking about that. So one thing that struck me was the fundamental idea of programming is basically very simple, right? It's you take simple ideas and then you compose them to build bigger ideas from that. So that's basically the fundamental idea. Now I want to take this thing and actually see how long you can actually go on this path. So I'm going to take a challenge. Okay, given a circle, ability to draw a circle, and Python, given these two to you, what all can you create? Okay, that's the challenge. Okay, so I'm going to actually write Python code right now and actually see what all things are actually possible with circle. Okay, so we're going to start with very minimal, right? I mean, just one circle. We know how to draw a circle, and we know Python. There's nothing else that we know. Okay, so let's get started. So let me start fresh. This is small web interface I built to kind of write code, especially just for the Keynote. So what you can do is draw a circle. This is what is given to us. Draws a circle. Now it's kind of quite confusing. Like, what is it doing? So let me put a grid here to for a reference. So here the top left corner is a point 0, 0, and we're drawing a circle at center 300, 300 with a diameter of 100. So that is the circle it is drawn. Okay, so this is what given to us. Now what all we can do? Okay, what all can we create just by circle and Python? Now let me try putting one more circle there, right? I can say circle 300, 300, and 50. So I put another circle inside. That looks like a donut. Okay, let me write a function donut, take x, y, and b. Then does something similar. Sorry. Yep. Take x, and y, and I'm taking b by 2 so that it will draw in the center. Now I can actually have took the circle and we to create a donut. So let's say 300, 100, and 200. It gives a bigger donut. Okay, what else can we do? Okay, now let me try back to the circle example 300, 300, 100. We put a circle to the left of this. So that would be to move x to the left. So I'll reduce the x value. That would put two circles. What if I want to put one more circle on the right? What if I put a circle on the top? That would be reduce y, and one at the bottom. That looks slightly interesting. Put a bigger circle. So each circle is of diameter 100. So all of that becomes 300. I can actually draw a bigger circle here. So I'll draw a bigger circle. That looks like an interesting shape. Okay, so let's give it a name. For lack of better names, we're just going to call it a ball. Okay, we're going to do what we're doing is we took a circle and trying to create different shapes with that. Okay, it's going to be x, y, and d. The x, y, and this is going to be 1/3 of the bigger circle. That's going to be d by 3. Now it's going to be x minus d by 3, y and d by 3. This is x plus d by 3 because it's going to come to the right. This is y, and this is d by 3. So similarly for y, we can just take that out. Y minus d by 3, y plus d by 3. Let's see. Okay, let me call a ball. That would give me the same thing. So I'll just call it for 200. Smaller ball. We have two things. We have a circle. We start with circle. We have a donut and a ball. So let's see. Let's say we want to fill the whole space with circles. How do we do that? So let's say I want to draw all circles in one row, right? So for in range n, so I'll take n as whatever value. I'll take n as 6. I want to draw circles here. Okay, so circle x, y, and I don't know what x, y, and d are. Fill in these numbers. What I'll do is actually here size is going to be, the width is specified, is already defined. It's going to be 600 in this case by n. Whatever n is, the size is going to be that. Okay. So y, so let me just put 100 for now, and d is going to be size. And it's going to draw a circle, but I want to kind of continue to draw here. Okay. So y has to be size by 2, so that would start from the top and then come here. Okay. For the x, it has to keep moving because I want to draw multiple circles. It's going to be I into size plus size by 2. So that would actually draw circles in a row. I want to fill the entire grid with circles. So what do we do? So I have to write one more loop for j in range n. Simplicity, we're just taking a square grid. Just like we did it for I plus size, here we're going to do j plus size, j into size. That fills the entire grid with circles. That looks interesting because now I can change the value of n and do it, but let me convert this to a function. Def grid n, it draws this grid. Okay. Now I could say the grid of 4 or 10 and 16. Like you can create as much big grid you want. That looks good, but what if I want to kind of do something else? What if I want to, let's say, draw donuts in the grid? That's going to be tricky. One thing we can do though is we can actually pass the function that you want to draw as an argument. Instead of saying draw circles always, I'll say specify what shape to draw. Say draw circles, and let's say 10, that will draw 10 circles. But if I can say donut, I will draw 10 donuts. Or I want to draw 10 balls. Right? Now we started with really circle, one simple circle. We created abstractions to create a donut and a ball, and then we figured out a way to put things in a layout. And now we can combine all these things and actually create so many variations. Is that all? Can we do something else? Okay, let's see if we can create concentric circles. So let's try. Trying to kind of see how much we can stretch, right? It's going to take x, y, t, and how many concentric circles you want to draw. Say that as n. Since we're going to have them equidistant, the delta for each one of them is going to be the d by n. So I'm going to do for I in range n. So I'll start with n. I'll go all the way to 0, increment of -1. I'll draw a circle. Center is going to be the same. The diameter is going to be delta into I. So for each loop, I want to draw a cycle of different size. Now I don't need the grid anymore. Concentric circles, 300, 300, let's say 600. We'll draw 10 concentric circles. Well, if I want to have 20 of them, I just need to pass n equal to 20. Now we have concentric circles. Looks good, but can we put this in a grid? That would be interesting. Let's try. Just like we had a grid there, I grid with the concentric circles. That looks really nice. Maybe make a grid of size 6. Right, so that's something else we created. Now we started with circle, we created a grid, we created concentric circles, then we combined all of them and made this. Okay, this looks good. Everything is kind of looks well, but can we do anything more than this? Okay, now one of the things is all we're doing is quite deterministic. There's no surprise element here. Okay, let's add a bit of surprise. How do we add a surprise? By introducing a tinge of randomness. So let's add randomness here. I'll import random module. Don't think we need a grid anymore. Okay, So what I'm going to do is, instead of having concentric circles, let's have actually random concentric circles. These circles actually have the same size. It's kind of there's no surprise. So let's kind of have a random concentric circles. So it's going to work like this, but I don't really need to have a delta because I'm going to put diameter as random. So I'll say it's d into random dot random. Random gives a value from 0 to 1. So that is going to be give me draw circles at random. Okay, so let's try this function now. I'm going to try 300, 300 and 500. Every time you run, you're actually going to get a different shape. Okay, so this is kind of surprise element. Okay, now every time you run, it's going to give a random circles. So that's fun. It's not fun just to look at one of them, but actually put them in a grid and see. I'm going to put that in a grid now. See, that looks now quite interesting. You increase the size a bit. That looks really pleasing. And you make it into 16. That looks like quite interesting. Like you'll see, like there's so many interesting patterns that come out of that. Well, so far we kind of started with a simple circle and kind of created something that looks non-trivial, so pleasing. Okay. Now, is there anything else we can do with circles? Something more? Well, let's try a small variation. What we did was we took circles and then changed the radius. What if we actually take the concentric circles itself, but instead of changing the radius, let's see if we can change the center a bit. Okay, so what I'm going to call it is, I'm going to call it concentric circles. Okay, I'm going to look exactly like concentric circles right now because I've not changed anything, but let's put the function in so that we can try that. Okay, that's going to give this. Okay, what I want to do is I want to kind of say dx equal to 10, dy equal to 0. Okay, and I want to say dx x plus equal to dx y plus. I'm incrementing, changing the center slightly. It kind of tilts towards that. Okay, so if I the difference between these two is actually delta. So if I say it's delta by 2, that's going to go all the way to the end. I want to kind of don't go all the way, but I want to kind of somewhere in the middle. So I'll actually say delta by 4. That will actually go tilt towards the right. How do I tilt it towards the left? I'll put minus delta by 4. Can do the same thing with y. Right? So both x and y are changing. Now I don't want to do it like this. I want to do it at random. So what I'll do is one. It's picking to go to the left or to the right or not go anywhere. Okay. When I do this, it will go to either of the directions. Keep trying it, you keep getting a different shape. Right? So that looks really interesting, but now it's looking at one is not fun, but put that in a grid and see. So let me put it 4 of them. That looks interesting. Let me put 8 of them. That looks even nice. 16 would probably be really too big. Yeah, I don't know if you can see that really, but let me just put 10. But if you see, like it, every time you run, you get a different shape, and this looks quite pleasing, right? I mean, all we did was started with a simple circle, use the simple ideas of programming to kind of combine these things and create something that look non-trivial, right? So this is generative art. So we're kind of generating art by by writing programs, right? And every time you run, a new kind of picture comes. We don't even know like what's going to come out. So it's so much fun to kind of try playing with these kind of ideas. Okay, now let's quickly see what all we have done with circles. What we did was we started with a circle, and then we created a donut, and then we created a ball. We created concentric circles. Then we tried to put in a grid. We put the circle in a grid, we put the donut in the grid, we put the ball in the grid, we put concentric circles in the grid. Then we try to kind of add a tinge of randomness to it. Now we have random concentric circles. We put that in the grid. That looks so pleasing, but we thought let's try one more variation of that. Then we try to change the center to a bit, and this is the pleasing pictures that we got. Okay, now this is something that we could do in 15 minutes, and this is just the tip of the iceberg. There's so many things that you can do. Take a simple idea, right? We started with only circles, nothing else. You can try the same thing exercise with taking a single line and see what all things you can do with it. So there are so many possibilities, and you can start with something and actually keep on going and trying so many different things. Okay. So now that we have kind of tried some fun with circles, let's try to see if we can take another challenge. Okay, the challenge 2, what if I take a fish instead of a circle? What else can we do? Well, so this is not a simple fish. This is a quite sophisticated fish. This is a fish that amused so many mathematicians for about half a century. Okay, so let's dive into it. So I'm going to show you a fish. This is a fish that we have. What I'm going to do is to get a better understanding of what the shape like. I'm going to add a border to the fish. Okay, that is the fish that we have. Now, what all we can do with the fish? So, for reference, I'm going to show a thumbnail. That's the fish that we have. Okay. Now, there are some primitive operations that we can do in with the fish. So let's kind of list down what all fundamental things, what are primitive operations that you can do. Okay. The operations that we support are here. We can actually do a flip. We can flip the fish. For example, I'll say is equal to flip the fish. And I need to show this. Okay. I need to stop showing this. Yeah. So what I'll do is I kind of add an offset, so the margin, so that it comes to the center. And I can also scale this so that you can see the bigger one. It scales to the available size. Okay. Now this is the original one, but I tilted that. So it's flipping it around the vertical axis. So you'll take this original fish, you take this thing and then flip it around the vertical axis. So now let me kind of add that also to the thumbnail, so that we can have that for reference when I do other things. Okay. Now the other operations that we can do are we can actually flip, and we can do a rotation. It's called rot. It rotates it anti-clockwise. So if we try with rot, it's the original fish and it's rotated anti-clockwise. So we get this fish. So we can try rotate and rotate multiple times. You can try rotate twice. That would get rotated once again. So let's look at the fundamental operations again. And I'm going to just put it here. So we have fish flipped and rotated. There's also other interesting operation called rotate 45. This is kind of tricky because what happens is when you rotate a fish, if you look at the actual original fish, right? I mean, let's say the unit is 1. If you look at the diagonal, the unit is going to be root 2 because this is 1 and 1. It's a right angle triangle. So the diagonal is going to be root 2. So when you flip it by 45 degrees, the width of the figure becomes root 2 times the original figure. So we don't want to happen that. We won't actually have the same width. So what rot 45 does, it actually scales it down to fit the width. So it actually compresses that by a factor of root 2, so that it can play well with the existing things. Okay. So let's add the rot 45 also to our thumbnail. right? So we have now we have fish, flip of the fish, rotate and rotate 45. Okay, what more do we need? Okay, so there is a primitive called above. That is, above takes two shapes, puts it one above the other. It squeezes the height becomes half, and puts two shapes together. Right, so I can show you that here. Above. Okay. You can also do the same thing with beside. You can put them next to each other, one besides other. Okay, so these are the primitive operations that we have. But there's one more. Okay, beside. One other is over. You can put one over the other. For example, you could take fish and rotate the fish. Well, it's not very pleasing, but you could put that on top of each other. So let me try rotate once again and see what happens. See the magic? So this fish, I told you this is not a normal fish, okay? So this fish is kind of quite mathematical in that sense. For example, the face of the fish here and the tail of the fish exactly have the same curvature. So you can put them each other and they get interlocked. Similarly, the wing of the fish here and the body of the fish, they have the same shape, so they get interlocked. So that's not the only one. There's so many. We will see many of them. But over it, you can just take two shapes and then put one over the other, and that becomes a new shape. Now, let's see what else we can do with this. Okay. Now, given that we know we can do above and beside, let's see we can actually do a 2 by 2 grid. Okay, I'm going to call it portlet. Okay, takes P, Q, R, and S. Put in 2 by 2 grid. How do I put in 2 by 2 grid? Above, beside P and Q. I put P and Q next to each other, and I'll put R and S next to each other, and then put one above the other. That gives me quadruplet. Okay. Now I can actually try quadruplet and say fish, 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 fish. Put 4 fishes together. Okay. Or maybe I can try a 3 by 3 grid. I call it nonet. Nonet is for 9. So it's going to take PQR, S, U, V, W, X, and Y. Oh, I missed things. Or S, T. Yep. Okay. So the above and below already supports multiple arguments. So I could just take PQR, S, T, and V, U, and V, W, and X. Right, so let's try if we can do a nonet. Fish, fish. That gives a 3 by 3. So I already have a special shape called blank. You can just put a blank, that means you'll not get anything. Okay, so we have all things set. So we started with fish and there are some primitive operations. Then we created a quadrilateral nonet to create a 2 by 2 and 3 by 3 grid. Okay, let's try something interesting now. I'm going to take shape T, call it T. I'm going to put over, well, I think let me create a fish 2. Okay, I'm going to rotate fish by 45 degrees. Okay, so let's kind of see. Right, that's the fish 2. What I'm going to do is with this piece, okay, so Z equal to or fish. What would happen if I put both of them together? Well, doesn't really fit, but if you see, I can maybe flip the flip the fish 2 around and see what happens. Okay, flip the fish 2. Sorry. Flip. Yep. That kind of quite nicely fits in. Okay. Now, if you kind of see, it's quite extraordinary, like the fish that we have here. Okay. So if you look at this one, right? So this is the shape of this one. Okay. So this one, the edge here and the edge here, the ratio of these two is √2. Right? Because this is the scale by a factor of √2. So the length of this and length of the side here, the factor of them is √2, and there are many of those things like that. For example, if you look at this one and the edge here, the ratio of them is √2. So it's kind of quite carefully designed. I mean, a lot of kind of math went into kind of designing this shape. It's not something that I've designed. This is something that's been there for ages. We'll see like original source of it in a minute, but it's quite remarkable. But let's look at, there's a small gap here. What can you do here? Can maybe rotate the fish and put it here. I need to rotate it clockwise. Since rod rotates it anti-clockwise, I need to rotate it 3 times. Fish 2. Okay. That so that is that kind of looks in quite interesting shape. Okay, so I'm going to call it tile T. Okay, I'm going to call it tile T. I'm going to use it again in a minute. Okay, so we have tile T. I'll park this for some time. I'm going to create something else. What I'm going to do is I'm going to kind of take fish 2 and rotate fish 2 and see what we get. Okay, so let's say z equal to u, so that I can print it. So I took so this is fish 2, rotate fish 2 came here, and then if I rotate it once again, and if I do that once again, I'm going to turn off the thumbnails because we kind of already now know what these things are. That is, and also we probably don't need the border anymore. This is quite interesting, right? I mean, you could take a simple shape and then kind of put it 4 times and kind of get a nice thing. Okay, and the interesting thing is now this can actually interact with itself. So let's kind of see now, what if I say x equal to, what let u do, let's say is equal to x. I put it like 4 times more, the same thing I put it 4 times. Looks quite interesting. Let me take the margin out so that it can take the full space. That looks quite interesting, but why to stop here? I can go one more level and x, 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 and x. Well, I need to print y. That looks quite interesting, right? But why to stop here again? You can actually go and say y, 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 y. That looks quite interesting, right? Now, though it kind of looks nice, but there is something that I'm not quite happy with this, right? I mean, this is quite monotonic, right? Everything looks the same. I mean, that's not fun. Let's see if we can actually do something, add some more complexity to this. Okay, so I'll stop this. Okay, what if I actually create an on-it instead of this? Okay, I'll call this s. So I have a blank here. I'm going to call it underscore so that I can type it easily. Okay, I'm going to create a with all blanks. Start with, say z is s. It's nothing there on the screen. I'll put the tile u that we have got here. Okay. What can you put on the top? Okay, let's say if I try to put the T here, that's too big for it. Maybe I can actually make it into half, then it probably fit here. Okay, now how do you put it here? Okay, so now if you see, there are 4 sides to it and then the 4 corners. Okay, right, let's figure out what to do for the side. Right now side is underscore. I'll just put this as side here now. We're trying to do if we can put T as a side, but that's not working. But what we can probably do is create a quarterlet with just kind of making this like 1/4 of the size or half of the width. That kind of quite locks in. That's quite interesting, right? Now I may just have to repeat the same thing here, so I'll actually put the same thing here. Well, not really. I may have to rotate it to kind of fit in, right? So here it has to be rotation. That kind of fits in. Okay, this is quite amazing, right? So just kind of understand. I'll say side equal to. Right, so that shows in the blue color. So we took the side, we took the tile T, put it twice by rotating it, and then we created a side. So it has actually 2 parts which are empty in the top, but I want to put it on the left as well. I can't really take it and put. What I need to do is I rotate and put it. Okay, so here I can actually rotate this and then put it to the side. Right? Do the same thing at the bottom. I can rotate that, put it to the side, but I need to rotate it once again. That's interesting. Now I need to put something to the right side, rotate it 3 times to put it. So all we're doing here is we took the shape, it logged in here. So we took that, rotated once and put it to the left, rotated once again, put it to the bottom, rotated once again, and then put it to the right. Okay. What do we put in the corner? Because we just need to put in the same shape, but we have to scale it down. So I'm going to call it corner equal to. So we don't need to highlight this anymore. Quarterlet. Just everything else is, and then just the same tile as you. Let's see if we can put it in the corner. Yep. Okay, I'll highlight the corner. Okay, so that's the corner that we put it. So we add a border to blank so that we actually see where are the blanks. So this is actually the blank piece. So wait a minute. So well, there's so many blanks. Okay, sorry, that's confusing actually. Okay, let's see. So now this I want to put it here. If I actually bring it down and actually put it, if I put the corner here also, actually come and sit here because I'm taking the same shape and putting it here. I have to rotate it once to kind of put it there. So I have to do a rot on the corner that would actually fit in now. I have to do the same thing here, but one more rotation. And one more. And one more. That is looks really kind of nice, right? You start with just a fish, but this is something quite amazing picture. But do we need to stop here? Well, not, right? I mean, let's do one more level. Can we go one more level? So let me kind of call this side 1 and say side equal to side 1. Okay, but I'm going to create a side 2. I'm going to do the same, apply the same thing there, okay? But instead of that, I'm going to put the side here, okay? Let's see what happens. Side 1. Right, so put the same side there. So the same picture, so the same shape is kind of made small and then applied same place, okay? Now what to do for the corner? Same thing, right? And apply the same thing. So you just take the same thing here, corner equal to corner 2. So I don't know to change the code at the bottom. But if you look at, if I put a thing here, what I need to do is I need to put a corner. So I need to, so this is the corner 2 is, so I'll put a so here I'll put side 2, right? Side 2, side 1, and here I need to rotate that and put it. So this would be dot of side 1. Yes. Here you just need to put the corner 1. Right? Can you go on for one more level? Why not? Right? The side 3 will be let's take side 2 here and apply the same pattern. Corner 3, side 2 and side 2. Need to say side or side 3, corner 3. Now you go one more level. We can go on. In fact, you can write a recursive function kind of do that. I mean, I don't want to get there, but you can see like we started with a simple fish and did a simple operations of flip, rotate, above and below and over, and then we could kind of create such a fascinating piece, right? And of course, there is a bit of mathematics and all that involved, but see, like there's so much fun and such a profound thing we could actually do by just combining these simple ideas into something much more complicated. So let me kind of pause here and kind of summarize what we've done so far. Okay, we started with a fish. Then we look at some of the basic operations. We could flip a fish. We could rotate a fish in anti-clockwise or rotate by 45 degrees. That also squeezes it by a factor of root 2 so that the width remains the same. You can put one above other or one beside the other. Using these two things, we created a quarterlet and a nonnet. And we tried to create two tiles. We call this tile T and tile U. This is basically the fish, the original fish, and the fish 2, which is rotate 45 and flip version, and that is rotated and then put here. And the fish 2 is put 4 times in, over each other by rotation. That gave us these two tiles. So what we did was now we took a nonnet and put U in the center and try to see what should we do for the side. So we tried to create the side by putting the tile T 2 times with rotation. That gave us the shape. We rotated and then put the same thing all around. And then we put a corner which is actually the same as U. That gave us this shape. Now if you see, this is what we got out of that. Now we went ahead and kind of repeated it once again. So that gave us really interesting shape. Now if you see, like there's nothing complicated code. We're not using any fancy thing that you can't understand, right? I mean, just look at the code that kind of went in actually doing that. Right. So we created like T and U by putting fish 2 and rotation of that, and it's basic things, right? And we created a side by putting them in a quarterlet, and the same pattern applied a couple of times. Corner, same for the corner, and we put them in on it, and we're done, right? Just by kind of taking simple ideas and then putting carefully in a structure, and we could achieve something such a grand image. Now, so this is something that that you can do, right? I mean, this is just the tip of the iceberg. I mean, I just kind of touched very simple things, right? Took a small things, and then you can extend and create these kind of things. So let's go back and actually give a small history of like what I've done, right? This is a painting called Square Limit by M.C. Escher. M.C. Escher is a Dutch painter and sculptor. He explored a lot of mathematical ideas in his art. So this is one of the, this thing is a square limit. What we tried was a version of this. He has tried to kind of so many mathematical ideas. One, he played a lot with symmetry, tessellations. He also tried to do represent infinity in a finite space, right? I mean, if you see here, if you keep on going multiple levels, it will never go beyond that space, right? You can represent infinity in a finite space. So that's some other ideas that he has tried. Now, if you see, this is 1964, by the way, right? Almost 50 years before. In 1982, a computer scientist or a mathematician, because 1982, probably there isn't much difference back then. He wrote a paper called Functional Geometry, explaining how the texture painting can be represented in pure mathematics, in a mathematical algebra. And then in 2002, he rewrote the paper. He wrote a new version of the paper, saying that how it can actually be expressed in a functional programming style using functional composition. So this is what inspiration for actually whatever I've done. So there's nothing really new that I've invented there. I've just kind of tried that people have tried in different languages in Python, so that I can introduce to the audience of PyConfHyderabad. But the idea is like there are so many nice things and fundamental fun things you can actually do with programming. You don't really have to look for the new buzzwords, right? I mean, if you look at, so that's something that worries me, right? I mean, when you look at all the young programmers, they want to learn the new buzzword libraries and frameworks because they want to be on cutting edge. Not really, right? I mean, there's so much fun. If you really want to kind of learn something, you have to go deep and take something very simple, go deep and understand, right? I mean, if you really want to kind of go deep and just take help of dead people, right? And people have already done so much work, you just have to rely on that work and actually go and try to see what they have done. So there are so many different texture paintings you can try, and etc. So the other thing that I want to kind of give you an idea is there is this wonderful book called Structured Interpretation of Computer Programs. This is a book that came out of a course taught in MIT called with the same name. This is written in a programming language called Scheme, a variant of Lisp. They have a chapter called the picture language. They try to kind of try these kind of ideas in Scheme. It doesn't really matter what language you're using, but you can try those kind of ideas and get your hands dirty and have fun. I would like to leave with a challenge for you. Okay, can you do this? Just like what I did for the fish, you take the Python logo and actually see if you can create that kind of tessellations and create this shape. Okay, that's pretty much what I have to cover, but I have a couple of references for you if you want to kind of go further. Functional Geometry paper by Peter Henderson is a wonderful resource. A person named Seshi Gowda is one of the contributors to Julia language. He wrote that in Julia. You can Google for that, you will find that. In fact, I've taken the fish image from his notebook. The Structured Interpretation of Computer Programs, the book I've shared already, and there's a wonderful book called The Gödel Escher Back, Eternal Golden Braid. So the author Douglas Hofstadter tries to look at parallels between the work of Gödel, Escher, and Bach. Gödel is a mathematician, Escher is a painter, and Bach is a musician. He tries to kind of get the kind of patterns which are kind of common themes across all these people, and it's kind of wonderful read. And of course, you should check out MC Escher because it's quite inspiring. And the credits for the fish image goes to Seshi Gowda because I've taken it from his thing. Thanks. And all the code that I've written is available in this repository. In fact, what I have is very simple web server so that I can actually take the Python code and run it and show the image. It's rendered as an SVG image and then shown. There's nothing complicated. You can look at the code, what is there. And that's it. Thank you so much for staying back. And I think we have time. We can go for questions.
Yes. Thank you, Anand, for the joyful talk. So, yeah, we have some time for questions. So if you all would like to ask any questions, we can go for it. You can post the questions in the Q&A section. Looks like they have enjoyed it so much and they didn't think there are no questions already.
Yeah, just wait for a minute and see if there are any questions.
Okay, so we have got how much time you took to prepare this talk?
Well, so it's kind of hard because I've been experimenting with these ideas for almost last 3 months because I'm teaching programming to kids. Okay, so it took me time to kind of port some of these ideas to Python because there's nothing like that available in Python. So I wrote a simple library. So it took me a while. I mean, I can't really kind of maybe like the core part is really not that much because I've been practicing and figuring out what's the right thing to present. Right? I mean, actually, what I presented today that didn't take me more than a couple of days. Okay, but I've tried so many things that didn't come in, right? I mean, tried so much and I wanted to try so many different ideas, and I wasn't happy with them. So that whole thing kind of took me kind of on and off. I was been doing for the last month. So not only for this, but I've been like teaching programming for kids, the same functional programming ideas. So in a sense, like there's so many things I wanted to kind of I tried but didn't make it to the talk. So in that sense, like that would take on and off across the whole month. I couldn't spend the time, but whatever I kind of covered didn't take more than a couple of days.
All right. So, any other questions?
Yeah, so you can reach out to me if you want. You can. That's my Twitter handle, Anandology. You can ping me on Twitter or drop me an email. That same thing, anandology@gmail. Happy to answer. I would love to see more people trying different ideas and then explore the joy of programming.
Yes. Okay. So, I think we have one more question. Very inspirational talk. That IDE was also great. When are you offering course?
Well, I'm not planning to offer a course per se, but I have actually created some course material on JavaScript. I'll probably, I mean, it's public, but I haven't published it anywhere. But I'll probably publish it soon. So it's basically starts with simple circle and line kind of course on building different ideas, and has a lot of exercises for especially young programmers to kind of try those ideas and then get the ideas of for loops and other things. Well, one of the problems is like when you teach Python programming to people, right? I mean, it's so abstract because that doesn't relate to what they already know. So let's say you want to try convert Fahrenheit Celsius, it's not fun at all. Okay, so at least earlier I used to have this belief that learning Python is a very good language to teach programming for newbies, and my ideas kind of changed in this experience. I mean, I'm not saying that Python is bad, but just putting Python alone is not enough. Okay, so I've actually worked with kids who actually had Python in their syllabus and they were not really enjoying programming. Okay, what is more important is what they're doing with programming rather than actually what language they're using it. So Python is probably a good language, but if they try to learn Python like C, it's not fun at all. So I found that using creative coding, like use code to generate art, is very wonderful medium. One, it gives a visual feedback. If something goes wrong, there's no way that you don't know it because the circle has to be touching each other. It's not touching now, right? It's going somewhere else. It's off the place. So you immediately know that the immediate visual feedback is something makes them really understand intuitively how programming works. So that's something that I've learned from doing that, and I don't know if we're going to offer the course, but we'll probably share it soon.
All right. So we have one more question. Any plan to write small book for kids on joy of programming?
Yeah. So true. Yes. I mean, I have some of the plans. So the one that I have, I don't know if I want to call it a book, but yes, it's a resource that I've been creating. I'll publish it sometime soon. I've also been exploring some of the ideas about actually looking at programming actually unplugged in the sense like, can we teach programming ideas without even actually using a computer? I want to kind of calling it programming unplugged. So people can actually look at simple ideas like take very simple ideas like you can move forward, move right, move left, and actually ask kids to draw a shape. So they have to kind of use the arrows up, right, left, etc. Or you can say move forward. So use kind of different mini languages to kind of introduce ideas of programming. The idea is basically you take something and then explicitly say the instructions so that a stupid computer can understand, right? So that if you can introduce to kids without even I feel like you don't even need computers for some of these things. So I've been exploring with those ideas. I haven't gone too far on that, but when I go something, I'm sure we want to kind of see if you can write something and then share it in a way.
All right. So, any more questions? We have 5 more minutes. I think we don't have any more questions. So I think we are good to.
Yeah,
Okay, so thank you everyone for skipping your India versus Australia ODI. I think it's been justified. So you might all have got really good, charge from this session. Thank you so much, Anand, for this joyful session.
yeah, it's my
So yeah,
pleasure to have the privilege to give the closing keynote at PyConFhyderabad. Thanks, everyone.
so this is really a great way to end the conference. So yeah, thank you so much. See you all. I think the ending note will be happening next. So please head out to the ending note. Thank you. That was really good, Anand. Thank you so much. All right.